Okay. So if we look at lesson number 5 is on geometric sequences. It says, consider the following two sequences. Explain how I would calculate the fifth and sixth sequence, or fifth and sixth term for each sequence. So for the first sequence, 2, 4, 6, 8, how would I calculate the next two terms? Add 2 to each one. So what would the next two terms be? 10 and 12. Okay. If I look at the second sequence, 2, 4, 8, 16, how would I find the next two terms? By doubling, which would be the same as multiplying by 2. So the next two terms would be, thank you. So the second sequence is what we call a geometric sequence. A geometric sequence we get by multiplying the previous term by a common ratio. So if I take 4 and I multiply it by 2, I get 8. Take 8 and multiply it by 2, I get 16. So for example, 3, 6, 12, and 24 is another geometric sequence. I start with 3 and I multiply by 2 each time. So in the example above, the constant would be equal to 2, because that's what I'm multiplying each subsequent term by. So when we had an arithmetic sequence, we could find that common difference through subtraction. When we have a geometric sequence, we find that common ratio through division. And we take any two consecutive terms and we divide the one term by its previous term. So T1 divided by T2 divided by T1, T4 divided by T3. So it wouldn't matter which two terms I picked. 6 divided by 3, 12 divided by 6, 24 divided by 12. I get 2 each time. So that's the first thing, common ratio. We use R to designate common ratio, R for ratio, D for difference. So our common ratio is the quotient of any two terms. And N has to be greater than 2. So I have to have at least the second term and the first term. I can't have the first term and no term. That's all this right here means. So in class example number 1, explain why each of these is a geometric sequence. So 6, 12, 24, and 48, why is that geometric? Common ratio is 2. -1, 5, -25, 125. -5. And I can get by going 5 divided by -1, which is the same as -25 divided by 5, which is the same as 125 divided by -25. I still get -5 each time. What am I doing in C? I'm multiplying by 1/2. So dividing by 2 is the same as multiplying by the reciprocal. Reciprocal of 2 would be 1/2. So I multiply by 1/2. And again, if I took any two terms and I divided them, I would get 1/2. -5/2 divided by -5 would give me 1/2. -5/4, divided by -5/2 would give me 1/2. So in class example number 2, we're going to identify if it's arithmetic or geometric, find the common difference or the common ratio depending on what type of a sequence it is, and then the next two terms. So if I look at A, 8, 24, 72, 216, arithmetic or geometric? How I tell it's geometric just by looking at it without grabbing my calculator and figuring anything out? Yeah, if I look at this, I know that the difference between 8 and 24 and 24 and 72 can't be the same. So if I can eliminate an arithmetic, then I can focus on the geometric. I can check if it's a geometric by looking for that common ratio. So what's 24 divided by 8? Okay. Do I get the same thing if I go 72 divided by 24? And I want to make sure this is geometric, so I probably want to do that twice. I probably want to check 2 spots to make sure that I'm multiplying by 3 each time. So this would be a geometric. There's my common ratio. So what would be the 5th and the 6th term? And the 6th term? $1,944. Thank you. Okay, look at the next one. Part B. Is this geometric or arithmetic or neither? Actually, neither is not a choice. It has to be arithmetic or geometric.
Arithmetic.
How do you know?
The difference between each of them is negative 36.
Okay, so my common difference becomes negative 36, which makes this an arithmetic. And one that can help is right here, because if this was geometric, I'd have to be able to multiply by something to get 0. The only thing I can multiply by to get 0 is 0, which means everything else would have to be 0. So what would be the next 2 terms? What would be the 5th term? Negative 36. And the 6th term? Part C. Negative 3, 2, negative 4/3, 8/9. Can I eliminate this as being an arithmetic?
Yeah.
How?
Well, the difference between negative 3 and 2 is a lot bigger than probably the difference between negative 4 over 3 and 8 over 9.
That, and if this was arithmetic and I was doing common difference, would it make sense to have a positive then or a negative, then a positive, negative, and a positive? Would that happen in an arithmetic sequence? No, so that means this has to be geometric. Because it has to be geometric, I can then find my common ratio. I take one term, divide it by its preceding term. So I get 2 divided by negative 3, bring the negative out in front or to the top, and I get negative 2/3. I could check this. If I went negative 4/3 divided by 2, I could check to see, do I get negative 2/3? And the answer is yes. So I could double check. So this time, if I'm finding the 5th term, I'm going to take the 4th term and multiply it by negative 2/3. And what would I get? And then to get the 6th term, I'll take that negative 16 over 27 and multiply it by negative 2/3 again. So what I want you guys to work on for the next 10 minutes or so is question number 1, question 2, A, B, and E, 3, and 4A. Okay. We're going to investigate the formula for the general term of a geometric sequence. So it says, consider the following scenario. A university marine biologist considers or studies the growth of a strand of moss by observing the change in its weight every day. So the table shows the mass of the moss in grams at 12 noon on each of the first 4 days. So in day 1, it had a mass of 8 grams. Day 2, it was 12. Day 3, it was 18. And day 4, it was 27. These masses form a geometric sequence. To find the common ratio, I take any 2 terms and divide them. 12 divided by 8 is the same as 18 divided by 12, which is equal to 1.5. So my common ratio would be 1.5. If I told you that the common ratio was 1.5 and that the mass of the moss was 8 grams on the first day, we could use that to find out the mass on each of the next 4, 5, or 10 days. So the first day, the term would be 8. T of 1 is the same as that A value, which is the same as what we did when we started off with an arithmetic sequence. A was our first term. T2, I get by taking 8 and multiplying it by that ratio. If I take 8 and multiply it by 1.5, I get 12. That's the same as taking A and multiplying it by R. In the third day, I take that 12, which I got from going A times 8 times 1.5, and then I multiply it by 1.5 again. Well, that's the same as going A times R squared, R times R. For the fourth day, it's the same as taking the term from the third day, which was that 8 times 1.5 times 1.5, and multiplying it by 1.5 again. And that gives me my value of 27. In terms of A's and R's, it's the same as taking my A and multiplying it by R to the power of 3. So then on the 5th day, I would start off with the term from the 4th day, which I got by taking 8 and multiplying it by 1.5 3 times. And then I would multiply it by 1.5 a 4th time. What do I get for an answer? So in terms of A's and R's, how would I figure out T of 5? So if I had the nth term, meaning it could be the 10th term, it could be the 20th term, it could be the 75th term, how would I use A's and R's to find out what the term number would be? N minus 1 is always 1 less than the term number. So the third term was R squared. The 5th term was R to the power of 4. So the nth term would be R to the power of n minus 1. So the formula for the general term of a geometric sequence is T of n equals A times R to the power of n minus 1. And that's outlined below. The only thing to just realize is sometimes you'll see the formula written as A times R to the power of n minus 1. Sometimes instead of A, it'll be T of 1, meaning the first term. So A and T of 1 are used interchangeably. Remember, n is the position of the term being considered. So if n is equal to 7, we're talking about the 7th term. Okay? It says, apply the following pattern for the terms of a geometric sequence. First term, the second term I get by multiplying by r, multiply by r again, so it becomes r squared, multiply by r again, it becomes r cubed, all the way up to the last term. So let's do some more examples. Determine the formula for the general term and then calculate for the indicated term of each of the following. So if I calculate, or if I determine my general term, a times r to the power of n minus 1. In this sequence, what is a? What is r? 3. And I can figure out it's 3 by going 15 divided by 5. There's my 3. So I get a times r to the power of n minus 1. That's how I can write it. So then if I want to calculate t of 9, wherever I see an n, I would substitute in a 9. So it'd be 5 times 3 to the power of 8. And what would I get? Okay. So if I look at the next one, t of n equals a times r to the power of n minus 1. So I want to figure out what r is. So r is going to be negative 1/6 divided by 1/3. What does that equal? So then I've got a, which is 1/3, times r, which is negative 1/2, to the power of n minus 1. So if I'm calculating t of 7, I would have 1/3 times negative 1/2 to the power of 7 minus 1. Or 1/3 times negative 1/2 to the power of 6. And what would I get as a fraction for an answer? What'd you get, Evan?
Negative 1 over 192.
Okay, I agree with the 1 over 192. I don't agree that it's negative. Did you put brackets around your 1/2?
Oh, no.
Okay. You have to put the brackets around the negative 1/2 because this means negative 1/2 multiplied by itself 6 times,
Okay.
which means my answer would then be positive. Okay? So what we're going to look at in the next example is trying to determine the number of terms in a sequence. And there's a couple of ways that we can do that. So Janice and Gary are trying to determine how many terms there are in the sequence that starts at 32, goes to 64, goes to 128, and then goes all the way up to 16,384 without having to write them all out. Okay? Because really that could be one strategy, is you could just keep filling it in and writing it all out. So if I use the general term, t of n equals a times r to the power of n minus 1. Do I know what the nth term of this sequence is? That's my 16,384. Do I know what the first term is? Pardon? 32. Okay. And do I know what my common ratio is? Then what can I do at this point? Could I get rid of the 32 on this side? How? I wouldn't subtract it. Why divide?
Because it's being multiplied.
These two things are being multiplied, so to undo it, I have to divide. So if I take 16,384 and divide it by 32, what would I get? So there's my simplified equation. That's the equation that I would have to try to solve. So there's two ways I could solve this. I could kind of use a guess and check method, or I could use a graphing method. And then next year I'll show you a third method, which would be the algebraic method. So if I use this guess and check, the algebraic has to do with logs. They're fun. I like logs. If we try this guess and check, what we're going to do is we're going to take 512 and see if we can write it as 2 to the power of something. So that's where the guess and check is going to come in. Grab your calculator and tell me, what is 2 to the power of 5? Okay, so that seems too low. So let's jump up. What's 2 to the power of 9?
512.
So I can rewrite 512 as being 2 to the power of 9. Well, if 2 to the power of 9 equals 2 to the power of n minus 1, what do I know about my two exponents? It would have to be 10 minus 1, because these would have to be equal to each other. I can ignore the bases, and I can just look at the exponents. And then, like Rachel said, it would have to be 10 minus 1, so n would have to be equal to 10, which means there would be 10 terms. So that's one way. The other way is I could graph this, and that's what Gary did. Gary said, let y1 be equal to 512, and then I'll let y2 be equal to 2 to the power of n minus 1. So if I was to grab my calculator to do that, so y equals 512, and then 2 to the power, and I need brackets. And then I have my x minus 1. Now I need to adjust my window settings. In my window settings, x represents that exponent number. Okay? Go from 0 up to 15. My y values represent what my where my intersection is going to be. And I already know that y1 has to be equal to 512. So my graph has to go up to 512 so that I can see that line. So 0 to like 600. Go up by 100s. And then if I press graph, there's my 512 line. And there's my 2 to the power of n minus 1. And then what I want to find is the intersection. So that's second calc and intersect. And then I'll scroll close to that intersection point, press enter until I press enter 3 times, and then I get intersection. And there's my x equals 10. So that's the other way that I can find this. So the tricky part with this is going to be making sure you use the right window setting. So my x's, I went from 0 to 15 going up by 1s. And my y's, I went from 0 to 600 going up by 100s. And then I went intersect, and I got that x equals 10. So questions for you to practice on would be question 5, A, and C.
I thought it was Thursday today.
Okay.
I thought it was Thursday this morning too.
So this continues from yesterday's lesson on geometric sequences. In arithmetic sequences, we looked at arithmetic means, inserting numbers between two terms so that I create an arithmetic sequence. We're going to do the same thing with a geometric sequence. If I have the number 81 and 1 over 729, and I wanted to insert 4 numbers, what would those 4 numbers be? So if you visualize it, this is what it looks like. So the hint or the clue is to think of the 2 numbers as being the last term and the first term of your sequence. So if I have the last term, so if I use my formula, T of n equals a times r to the power of n minus 1. T of n is my last term. That's my 1 over 729. A equals 81. And r is my unknown. That's what I'm trying to figure out is my common ratio. Can I figure out what n is? Yeah, 6. There's 6 terms.
She didn't say anything that's wrong.
You seemed very hesitant. So 6 minus 1 would be 5, so I'd have 1 over 729 equals 81 times r to the power of 5. Which, if you look at this, times by r once, twice, 3, 4, 5 times, I get to the 1 over 729. So how do I solve this? What do I have to do first?
Divide by 81.
Divide by 81. So what is 1 over 729 divided by 81? Not as a decimal.
Can I borrow it away?
Yes, you may. I would assume you're not the only one that needs to.
Yeah, okay, I was thinking it was like that.
Yeah, so did I.
So what do I get? If I tell you it starts with 59,000, would that make you feel better?
No.
No, yeah.
9,049.
Okay. Dividing by 81 is the same as multiplying by what? 1 over 81. So if I look at this side, if I take 729 and multiply it by 81, I will get that 59,049. How do I go from r to the power of 5 to r? I can find the 5th root. So the 5th root of 1 over 59,049 equals what? So if we go back to the calculator, yeah. So I have to press the 5 first so that I can get the root, the 5th root. My calculator actually takes that 5 and makes it look like an index. Some of yours won't. Some of yours will just keep it as 5 and then x and then the radical sign.
I can't even get the 1 over, or like the 1 over 59,000
Yeah.
on my calculator. It just keeps putting in the signs in my calculation. Yeah. And
When you press mode, what mode are you in?
degree.
Right here.
Oh, normal.
Normal. So 1 divided by 729 divided by 81.
Yeah, that's. And even if you multiply it by 1 over 81, you still get the same thing.
Okay. So because of that, that's why I showed you this part in here, because then if I'm multiplying fractions, 1 times 1 is 1, and then I would just multiply the 81 and the 729 separately. So sometimes it's just the programming of the calculator. The calculator is really not going to probably look at a fraction that is a 59 or 60 thousandths, because really that means you're taking 1 and you're dividing it into 59,000 pieces. That does not seem something to be able to visualize or imagine. So then if I do this fifth root thing, I've got 1 divided by 59,049. I don't need to put brackets in mine because my radical bar extends, but yours might not. So you have to experiment with your calculator. You may need a bracket, open bracket, and close bracket. And then my decimal that I can convert to a fraction, and I get 1/9. There is another way that I can do this. Instead of taking the fifth root, what I could do is have my fraction and then raise my fraction to the power of 1/5. That would be using exponent rules. 5 times 1/5 would equal 1, so then I'd raise this side to 1/5. I would do the same. So I can either take the fifth root of each side, or I can raise each side to the power of 1/5. That was the radicals that we did last year, and the rational exponents. I still get the same answer.
How'd you get the fifth root sign again?
5, math, and then it's choice number 5.
Okay.
Okay? So then if I multiply by 1/9, what is 81 times 1/9? 9. What is 9 times 1/9?
1.
And then 1 times 1/9 would be 1 over 9. And then 1 over 9 times 1 over 9, 1 over 81. And if I take 81 and I multiply it by 9, there's my 729. So then, what happens if both our A and our R are unknown? 3 consecutive terms of a geometric sequence are x plus 3, x, and x minus 5. Use the concept of a common ratio to determine the value of x, and then determine what the 3 terms are. So what it means by the concept of the common ratio, how do I find the common ratio in a sequence? So if my sequence is this, how do I find my common ratio?
Divide like the second term by the first term, like the third term by the second term.
Yeah, I divide any 2 consecutive terms. So if I take the second term and divide it by the first term, or if I take the third term and divide it by the second term, what do I know about the value of these 2 expressions? They're equal. So make them equal to each other. So then how would I solve this? Cross multiply first, so x times x will equal x plus 3 times x minus 5. And now I no longer have fractions to worry about, or the denominators to worry about. So I get x squared on the left-hand side. And on the right-hand side, we're getting to the point now when we go to FOIL this out, we want to try to simplify the process so that we don't have to take as many steps. So we want to try to do some of this mental math. So x times x gives me my x squared. My outside and my inside terms are going to collect. Negative 5x and positive 3x I'll get negative 2x minus 15. So the next step would be to do what?
Move all the x's to one side.
Okay? So if I move the x's to one side, like that, would that work? How do I get rid of an x squared? Subtract x squared. Get rid of a negative 2x by adding 2x. What happens to my x squareds? Cancel each other out. So now I have 2x equals negative 15. So then what will x equal?
Negative 7.5.
So negative 15 halves, which is negative 7.5. So then if I use that value of x to find my three terms, my first term was x plus 3. So negative 7.5 plus 3 would be negative 4.5. The second term is equal to x, which would be negative 7.5. And the third term is x minus 5. So negative 7.5 minus 5, which equals negative 12.5. If this fraction had been a repeating decimal, or if it had been a decimal with like 3 decimal places, I would keep it as a fraction. Because it's a decimal that is 0.5, I can use the decimal, but you have to also realize that fractions tend to be more exact, especially if it's a repeating decimal. I would want to have kept it as a fraction. Okay. The fourth term and the seventh term of a geometric sequence are negative 54 and 1,458 respectively. Use a system of equations to determine values for the first term in the common ratio and then determine the general formula. I don't think a system of equations is going to be our best option. 1, 2, 3, 4, 5, 6, 7. How do I go from negative 54 to positive 1,458? What do I have to do? I multiplied by what? I multiply by an r, right? So r once, r twice, r 3 times. So if I multiply by r cubed, I'm going to get 1458. How do I solve this equation? Divide by negative 54. So r cubed equals what? And then I will take the cubed root. And what's the cubed root of negative 20? So the cubed root of negative 27 is negative 3. So there's my common ratio. And then from here, if I work backwards, I can get to that first term. Or I can look at the fourth term is negative 54, which is going to be the first term times negative 3 to the power of 4 minus 1. Because this was t of 4. So that gives me negative 54 equals a times negative 3 to the power of 3. What's negative 3 to the power of 3? Negative 27. So I have negative 27 times a equals negative 54. So to get a by itself, I would divide by negative 27. And what is negative 54 divided by negative 27? 2. So there's a. And then my final step would be my general formula. T of n equals a times r to the power of n minus 1. So I get 2 times 3 to the power of n minus 1. Did you have a question, Bobby?
Wouldn't it be negative?
Yep. Because r is negative 3. Okay, the questions for you to work on. Did I give you questions up to 10 already?
Yes.
Okay. So then 12, 15, 16a, and 19 to 22.